Have you ever wondered just how enormous dinosaurs could grow? Picture a creature so colossal that it could make our tallest buildings look like toys. These prehistoric giants have captivated our imaginations for centuries, but the question remains, what were the limits to their size? In this video, we'll embark on a journey through time to explore the fascinating world of dinosaur dimensions and uncover the factors that determine their maximum growth potential. Our story begins with the discovery of giant bones that have puzzled scientists for generations. These fossilized remains tell tales of creatures that once roamed the earth, dwarfing anything alive today. But to truly appreciate the scale of these ancient behemoths, we need to look at some of the most impressive examples nature has ever produced. Let's start with Argentinosaurus, a titan among titans. This massive sauropod is estimated to have reached lengths of up to 100 feet. It may have weighed as much as 80 tons. To put that into perspective, that's about the weight of 12 adult African elephants combined. Imagine the ground trembling with each step as this colossus lumbered across prehistoric landscapes. But Argentinosaurus wasn't alone in the size department. Another contender for the title of largest dinosaur is Patagotitan, discovered in Argentina. This gentle giant is thought to have been about 120 feet long and weighed around 70 tons. That's like having a herd of modern-day elephants all rolled into one enormous package. While we're on the topic of giants, we can't forget about Spinosaurus, the largest known carnivorous dinosaur. This fearsome predator could grow up to 50 feet in length and is believed to have weighed around 7 tons. With its distinctive sail-like structure on its back, Spinosaurus would have been an intimidating sight. Whether on land or in the water where it's thought to have hunted, these examples of prehistoric gigantism are awe-inspiring. But they also raise a crucial question. What stopped dinosaurs from growing even larger? After all, if bigger meant better in the evolutionary arms race, why didn't we see dinosaurs the size of mountains? To answer this, we need to delve into the complex interplay of biology, physics, and environmental factors that govern dinosaur growth. First and foremost, we have to consider the basic needs of any living creature: food and oxygen. As animals increase in size, their metabolic demands grow exponentially. A dinosaur the size of Argentinosaurus would have required enormous amounts of vegetation to sustain itself, possibly consuming up to a ton of plant matter each day. But it's not just about how much food they could eat. The efficiency of their digestive systems played a crucial role. Sauropods, for instance, had incredibly long necks that allowed them to reach high into the tree canopy, accessing food sources that other herbivores couldn't. Their digestive tracts were also highly specialized, enabling them to extract maximum nutrition from tough plant material. Oxygen supply was another limiting factor. As body size increases, the surface area-to-volume ratio decreases, making it more challenging to absorb enough oxygen through the skin. Dinosaurs, like all reptiles, had a more efficient respiratory system than mammals, with air sacs that helped to oxygenate their blood more effectively. However, even this advanced system had its limits. The Earth's atmosphere during the Mesozoic era, when dinosaurs ruled, was different from today's. Oxygen levels were higher, which may have allowed for larger body sizes. But as the planet's climate and atmosphere changed over millions of years, it likely influenced the maximum size potential of these ancient creatures. Gravity is another force that cannot be ignored when discussing dinosaur size. As animals grow larger, the stress on their bones and muscles increases dramatically. The largest dinosaurs had to evolve specialized skeletal structures to support their massive weight. For example, sauropods had honeycomb-like structures in their vertebrae, which provided strength while reducing overall mass. The laws of physics also dictated how tall a dinosaur could grow. Just as skyscrapers have structural limits, so too did dinosaurs. The taller they grew, the more energy they would have needed to pump blood to their heads. This is why the longest-necked sauropods are thought to have held their heads horizontally most of the time, rather than in a vertical position. Environmental factors also played a role in limiting dinosaur size. The availability of food and water in their habitats would have been crucial. Larger animals require more resources, which means they need larger territories to sustain themselves. If resources became scarce, it could have put pressure on the largest species to evolve smaller body sizes or face extinction. Competition between species was another factor. Being large offered advantages in defense against predators and in competing for mates. It also made dinosaurs more vulnerable to changes in their environment. Smaller, more adaptable species might have had an edge. When it came to surviving in changing conditions, the evolutionary arms race between predators and prey also influenced size. As herbivores grew larger to avoid being eaten, carnivores had to evolve to keep up. This back and forth pushed both groups to impressive sizes, but it couldn't continue indefinitely. At some point, the energy required to hunt and kill such large prey would have outweighed the nutritional benefits. It's important to note that not all dinosaurs were giants. The fossil record shows a wide range of sizes, from creatures no bigger than chickens to the colossal sauropods we've discussed. This diversity suggests that there were many successful strategies for survival in the Mesozoic world. And being the biggest wasn't always the best approach. As we conclude our exploration of dinosaur dimensions, we're left with a profound appreciation for the delicate balance that nature maintains. The largest dinosaurs represent the upper limits of what's possible for land-dwelling vertebrates, pushing against the boundaries set by biology and physics. While we may never see creatures of such immense proportions walking the Earth again, the study of dinosaur size continues to yield fascinating insights. It helps us understand not only the prehistoric world, but also the fundamental principles that govern life on our planet. So the next time you look up at a tall building or marvel at the size of a blue whale, remember that nature once produced land animals that rivaled or surpassed these in scale. The dinosaurs may be long gone, but their legacy of size and the mysteries they left behind continue to inspire wonder and fuel scientific inquiry. In the end, the question of how big dinosaurs could get isn't just about measurements and numbers. It's a window into the incredible adaptability of life and the complex factors that shape the evolution of species. As we continue to unearth new fossils and develop more advanced research techniques, who knows what other secrets about these prehistoric giants we might discover?